guys, Mrs. Brummel here. This is the first video for 3.4. In this section, we're going to look at what are the derivatives of log functions. So one of these you already know. The derivative of the natural log of x is 1 over x. So what happens when we have a log that's not base e, that's not natural log? It's a log of any other base. So I'm just going to do this at the bottom here, you guys. And we're actually going to use something we already know. And we're going to use the change of base formula. So if I have log base a of x, we can use the natural log or we can use common log. I'm going to use natural log because that's the one I know something about the derivative of. And we can rewrite a log of any base just like this. So let's say I want to take the derivative of this. So the derivative with respect to x of natural log of x over natural log of a. Okay, so I'm going to use the quotient rule. So the derivative of the numerator is 1 over x times the denominator as is minus what am I doing here, you guys? I'm making this even more complicated than I need to. So natural log of a is actually just a constant. So I'm actually going to pull that out. I'm going to treat that as 1 over natural log of a times natural log of x. So then I don't have to use the quotient rule. So when I take the derivative of this constant multiple just stays out front. So it becomes 1 over natural log of a times the derivative of the natural log, which we know is 1 over x. So this, I can multiply those together and just get 1 over x times the natural log of a. So this is the derivative of a log function of any base a. So whatever the base is goes right there for a. So this is going to be 1 over x times the natural log of a. All right, now let's use that to find some derivatives. Okay, so we are going to be using kind of this new one here as well as the old one that we knew and the chain rule. So my outer function on this one is natural log of x, so 1 over my argument times the derivative of the inside, which is just 5. So this becomes 5 over 5x, which still simplifies to 1 over x. All right, this one, okay. I'm trying to remember how, this is kind of written funky, you guys. It was supposed to be like this, natural log of x squared, like that. Okay, so my outer function again is natural log. So when I take the derivative, I've got 1 over x squared times its derivative, so the inner function derivative would be 2x. Again, I can multiply those together, and one of the x's here is going to cancel with one of the x's here, so we're going to be left 2 over x. All right, so this is our common log, so this is base 10. So this is like the a here. Okay, so we are going to, the 1/2 is just a common multiple, so when I take the derivative, it's just going to be 1/2 times the derivative of this, which is 1 over x times the natural log of the base, which for us is 10. And again, I can write that as one fraction and say it's 1 over 2x natural log of 10. Oop. All right. Okay, here. This time I have an implicitly defined function. So we can either define this, actually this one's going to be a little more difficult to define explicitly, so I'm just going to use implicit differentiation. So I'm going to start differentiating. So I got 1 over x plus 1 over y dy dx equals 2. Okay, so I'm going to do 1 over y dy dx. And I'm going to subtract the 1 over x over, so I've got 2 minus 1 over x. And then I'm going to multiply to get rid of the 1 over y and get dy dx by itself. I'm going to multiply both sides by y. So the y and 1 over y will cancel, and we get dy dx equals y times 2 minus 1 over x. Okay, here, my outer function is log base 2. So we are going to say our derivative is 1 over x, but our x here is x cubed, right? And then times the natural log of our base, 2. and then times the derivative of our inner function, which would be 3x squared. So again, I can kind of see things are going to simplify here. The x squared is going to cancel with one of those x's, and so I'm going to be left with 3 over x natural log of 2. All right, this guy. We have a product. We have x times this. This is kind of the second piece. So using the product rule, derivative of x is just 1, and 1 times this guy, as is, plus x times the derivative of this. So this is going to be 1 over x squared plus 1, and then the derivative of this inside function is going to be 2x. So this is all multiplication, so I can put these 3 together. So we've got natural log of x squared plus 1 plus 2x squared over x squared plus 1. Okay? All right. Okay, and that's it for this first part of 3.4, you guys. There's a second video to go over 3.5. Thanks for watching.